All right, we are back with homework 3 for AI evals. So I'm going to walk through this assignment. Just as a reminder, the assignments we walked through before, homework 1 was basically creating a prompt for our recipe bot, and then running through a lightweight evaluation script. Uh, Homework 2 was generating synthetic data and going through and annotating our data and doing their analysis. Now we're on homework 3, which will be to create an LLM as a judge. So should be fun. So go ahead and follow along. I'm going to make sure I'm watching the stream this time because I've had issues where the stream cuts off. But anyway, let's get started. I'll go ahead and share my window. The core task is to evaluate adherence to dietary preferences. So if the user asks for a vegan recipe, we want to make sure that the recipe provided is actually vegan. And they provide 2,000 starter traces, and then detailed criteria. So they have 3 different options. One option is to start from scratch and generate our own traces and then label the data and then build the evaluation workflow. Option 2 is to start with the traces they provided. And then option 3 is to start with the labeled data. I think the best thing for us to do is really either option 2 or 3. To some extent, we've already gone through kind of the process of producing labeled traces, but it might be helpful for us to do it again, just so we're more familiar with this data. This kind of just duplicates a lot of work that we've done across previous homework, so I don't feel like there's a lot of value in redoing this. But if there were a different criteria you wanted to build an LLM judge around, then this would be the thing that you have to do. And that would involve creating the queries that you need to then create the traces and then go through and label the data. So I think what we'll do is probably just in the interest of time, just start with the labeled traces because I think the doing the raw traces, it's just something that's time consuming. So generally in my experience, you're gonna have to label on the order of like 100 queries. And with each query maybe taking a minute or two, like already you're into like the 2 hour realm. And so I think for the purposes of like being educational, I don't know that that's like a great use of time. And you can see sort of the process that you go through in homework 2 that I already streamed. So we're going to start with labeled traces and just focus on the evaluation methodology. So let's get started. So if through, step 1 is to get the data, get and label the data. So we're starting from the traces, so we don't need to do that. And then split your labeled data. So option 3, this is where we start. So we want to divide the data set into train, dev, and test. One thing you'll notice is that what we use for training data as a percentage is much lower than traditional machine learning. And this is because we're not really training the model on this data so much. We need a smaller data set to kind of like get the model to accomplish our task, because the underlying foundation model is so powerful. And in step 3, we're going to develop the judge prompt. And then with step 4, we're going to want to refine and validate the judge, to make sure it kind of works. And then step 5, we're going to want to measure it on new traces. And then we want to report the results with judgy. Cool. So that's all fine and great. Now there's some notes here on what the failure mode is that we're looking at. And so it's adherence to dietary preferences. And so when a user requests a recipe with specific dietary restrictions or preferences, the recipe bot should provide a recipe that actually meets those restrictions and preferences. So examples, user asks for a vegan pasta recipe, bot provides pasta with nutritional yeast instead of Parmesan. Fail, user asks for vegan pasta recipe, bot suggests using honey as a sweetener. Honey isn't vegan. That's actually news to me. I didn't realize that honey wasn't considered vegan. Cool. The more you learn. User asks for gluten-free bread, and then bot provides recipe using almond flour and xanthan gum. User asks for gluten-free bread, bot suggests using regular soy sauce, which contains wheat. Pass, the user asks for keto dinner, bot provides cauliflower rice with high-fat protein. Fail, user asks for keto dinner, bot includes sweet potato as a healthy carb. Cool. And so there's a bunch of dietary restriction definitions here too. So one thing I just want to say is a lot of this is really just kind of a rubric for how a human should go through and rate responses. But also, this is all useful information for the LLM judge too. And so, probably in a large sense, we're going to start just by copying and pasting a lot of this. We might avoid copying and pasting the examples largely because I don't know if these examples in some way appear in the data sets, and we want to avoid leakage. And so leakage, very often it's common and a good practice to put examples of inputs and outputs into your prompts so that your LLM responds in the ways that you want it to. But when it comes to evaluation, you want to make sure you're not accidentally giving the answers to the LLM. So it would be like having an LLM take a test. You don't want to put the answers to the test questions in the prompt because then you're not measuring whether the LLM can actually answer unseen user queries. You're just evaluating whether it can copy the answers from its prompt. And so your results end up being biased and you might end up being overconfident about how well your AI works. Let me go ahead and check the stream to make sure it didn't crash. Okay, I think we're good. I'm paranoid about it crashing now. If my stream crashes, I'm going to crash out. All right, so there's some samples here about challenging queries, contradictory requests. So I want a cheeseburger, but I'm dairy-free and vegetarian. I think that there's a way to make that. There's like fake meat and everything. I'm vegan, but I really want to make something with honey. Is there a good substitute? Ambiguous preferences, something not too carby for dinner, something keto-ish but not super strict, dairy-free but cheese is okay sometimes. Cool. A lot of stuff there. They talk about some of the key metrics to understand the true positive rate, the true negative rate, the corrected success rate, and the 95% confidence interval. And so, really, all of these things are about the AI judge as we build it. And I'll just talk more about how these come into play when we start building the judge. So the deliverables here, label data set, final judge prompt, performance metrics, final evaluation results, and then a brief analysis interpreting the results. Okay, and there's like a reference implementation. Cool. So blah, blah, blah. Cool. So I think from here, what I'm going to do now, we've basically gone through and talked about all of the instructions. And so I'm basically just going to make a new branch for homework 3. And then what I want to do is, I'm just going to create this main.py file where we'll do things. And for now, I'm really just going to do a simple, just list the steps that we're going to need to do here. So we're going to need to load the data set, the labeled data set. And then we're going to need to split the data set into 3 parts. Train, we'll say 20%, and then val. So people often call this validation or dev. Those are 2 common names for that. And then we want to basically write a judge prompt. And then go through an evaluation loop of the judge prompt. So the reason it's helpful for us to have the labeled data set is this is what helps us compute metrics about how well the judge is working. So I think that this is like fine. And then at the end, we'll want to like print out metrics about alignment. And so we'll want basically the accuracy, and then true positive rate, true negative rate, and also like 95% CI. Cool. So let's go ahead and start doing this. So the data set is in a CSV file. And so I'm just going to use pandas to load that. And I know that I'm going to end up using Mirroscope for defining the function. So I'm really just going to start out by adding this in because I know I'm going to use those. And so we want to pull in the labeled traces. And then we want to split it into 3 parts. This is something, there might be a simpler way to do this, but I know that there's probably like a simple available thing. But generally what you want to do is like shuffle the data and then so like one thing I might do is use sklearn model selection. So I can just like use this twice. And so I'll call this like dev test. And so we'll say that the test size is going to be 0.8. And so really what this is going to do is going to make sure that our train DF this is 20% of the data, this will be 80% of the data, and then we split it into 50-50. So then this is like 50% of the 80%. So this should be 40% of the original data, and this will be 40% of the original data. So the reason we want to have these 3 splits, by the way, we talked a little bit about the leakage of like not wanting to put the answers inside the prompt. So, that's what we'll use train DF for, putting answers inside the prompt, and that way we won't be leaking information. Then we'll basically be looking at how the model performs on the dev set and make changes to ensure that this, we are improving against this. And then after we've done doing all of our iteration, then we do a final measurement against the test data frame. And the reason you want to do that is somewhat for the same reasons that we don't want to put we don't want leakage of like the test data coming into the prompt. There's a more subtle effect where if I'm constantly looking at this dev data set to see what the judge does poorly on and then fixing it, I might subtly be making the judge work really well on this data set in a way that doesn't transfer to unseen data. And so it's a really good practice to have a data set that you never look at. I think there's some nuance and sometimes even disagreement about like how useful that really is. There are actually use cases where um, this is not done. Ads is one that comes to mind, where that's not really a common a practice, but it's still very good to make sure you aren't fooling yourself into building something that looks like it works well and doesn't actually work well. So now that we have that, we can go ahead and um, we have the labeled traces here. And this basically should have like a query, dietary preference, and then a success column. Um, so now that we have that, now that we basically just want to have a judge prompt and make the judge. And so I'll make the judge here at llm.call. Um, and so we'll go ahead and make this a structured output. So let me just add prompt template, judge prompt, and then we'll just call it judge, and then we're going to give it a query and response. And then we want to make the judge response thing. And so we'll have it do chain of thought by just adding a reasoning field. And then we'll say passes. And actually, one thing we might want to do is we'll basically force it to extract out the dietary preferences that it sees. Um, and then we'll give it that. So now we have like a judge response that gives us a bunch of stuff. All right. Um, we'll come back to the judge prompt. Um, so I'll just write something simple for now. So, um, you are a judge for recipe generation task. Please judge whether the following response passes the dietary restrictions stated in the query. So we'll just start with a really simple one. And here we go. So I have like a really simple one. We'll come back and like iterate on this. I'm going to actually close the terminal now so we can see a little bit more. So now we've gone through and we've loaded the labeled data set. We split the data set into our three parts. We wrote the prompt. Now we just need to go through like an evaluation loop. So I think really what this would be, let's see. I'm just going to make like a main function real quick, just for good practice. And so I'm actually going to move this load these down into the main function just to kind of keep the control flow. So now we basically want to go through and judge each of them. Because there's a lot, we might want to, and I'll even make this, I'll keep it mini for now. I don't want to waste money. So we could just go through these like one by one. Might be useful because there's 150 of them to do this like in parallel. And so you know one way we might do this is we can make this async, and we can even make this async. And so what we'll do is basically go through all of the items in the dev data frame because we're doing an evaluation against the dev set. We're not really using the train DF right now. We will as we upgrade our judge, but we can basically go through and asyncio.create task. And so we can basically pass a coroutine into there. And so we're basically just going to go through the dev data frame. And there. And, I already think because we're going to, measure this against a lot, we might actually want to expose this little snippet of code that we're writing to do an evaluation in concurrently. We might want to expose it. And async is a great thing to use here, just because this is something that's IO bounded, because we're going to wait for the LLM to respond for quite a while, and so we can basically end up firing off a bunch of requests, and then just wait for them all to finish. So, okay, so we have gathered tasks. So each task basically is going to return this. And so we now want to basically, for each one, we want to compare we want to end up comparing the query and the success of it. And so we might end up now saying something like, paired labels. And so we might want what is this? Oh yeah, preferences. Okay, yeah. I'm going to name this meets dietary restrictions. Cool. And then so we want to get the query, we want to get the dietary, I forget what it's called. Let's just open labeled traces real quick. Dietary restriction. And then success. Cool. Okay. So we got all of that. Actually, I guess in a sense, really what we need is like, actually, the easier way to do this is just to say labels equal dev df success, and then predictions equal that. Cool. Okay. And so now we can kind of just print out how well we do. And so there's a library that they tell us to use in this assignment. Called Judgy. That is not what I was looking for. Hmm. Okay, let me look it in the README real quick. I think there's like a, yeah, there we go. So I imagine it's already installed. Um, so we get the test labels, test predictions, and unlabeled predictions, and estimate the true pass rate. Okay, cool. So back in here, what we probably want to do is Jesus. And we can say like, uh, what else do we need to do? Okay, so we have our labels and predictions. Um, we now probably just want to see how well these two things align for now. I'm getting really tired of cursors autocomplete. It's like kind of garbage at times. Like sometimes I actually need to tab. And it gets in the way of me like doing an actual tab. Deeply annoying. So let me check that the stream's still on. Yep, cool. So we can basically just print out the success rates. So something that I'd probably do here, I would probably want to print something like, God, predicted success rate. And then I'm just going to use like mp.mean, actual success rate, and then we can basically do, I'm not going to do the 95% confidence interval right now because it's not using um, something that I want. But yeah, so I think that's pretty good. Now we can import NumPy. We've done a lot here. And so we can now start to see how well our judge does just kind of like out of the box without us having to do much. So let's see what happens. No such file. Oh. That's because I am in, what directory am I in? So I need to go into homeworks, homework 3, main.py. Let's see if this works together. Okay. It's interesting that it took so long, and then the thing that it failed on was this. Maybe it was like stalling in the background. Um, Something that might also be useful here is just to, so we don't have to continually um, rerun the judge if we run into like errors or something. It's good practice for us to just like save out the judge data set. And so the way we might do that is we now have these tasks. And so what I would probably do is something like, actually, let me do this too. Um, so I'd probably save judge results to a CSV file. And so then PD dot data frame of results. And then I would basically say like model dump so that this just dumps all the fields. And then I would do like dot assign and say like query ID equals, and then I would take the query ID um, um, from this data set here, and then I would also give a trace ID. And then probably you also want to like add into the file name something like the date. So something like it's kind of like a long thing, but this is something that now can help us make sure that we're saving everything that we need. So good practice, I would say. Um, I don't know how to make this prettier right now. There we go. Cool. So basically, we create a data set from the results, and then we assign it a couple of um, values. I don't think we need this, and I don't think we need this. But we give it the query ID and trace ID. That way we can kind of like correspond it later, and then we just save it to a file. And that way, you know, if we run this and it gets past this point, but then something here fails, then we don't need to like wait for the um, judge predictions again. Ah, list object. Oh, we need to do r dot. There we go. So I think that this got passed now. Homework 3 data, and we now see reasoning, dietary restrictions, and then whether it meets dietary restrictions. So we see that we got it. So that's super cool. So now we don't need to rerun this. We do have some other things, and that actually was way faster than I thought it would be. So that's pretty cool. But we don't need to like continually use a lot of tokens. So what I might do is um, Instead of running these, mm, so it's actually fast enough. I'm just like not even gonna bother right now. But I think the issue is that these predictions are not an NP array. Cool. So predicted success rate 0.9, actual success rate 1.0. This is suspicious to me. Very suspicious. So I'm going to look at these labeled traces. Basically, anytime you ever see um, a case where you have 100% on something, very suspect. So I'm now wanting to basically just like look through the data and see um, whether I want to look through the data to see whether the success rate is always one. And this may be a case where I just misunderstood the data setup. So we're going to import pandas here. I need to go ahead and select kernel, Python environments, use a VM. Okay. And so we'll do that. And then I just want to look at, cool. And so we have success and error. And so I'm wondering whether the success field might be like null or something or missing. So cool. So yeah, it only ever has success. And so let's also look at df.error. Oh shit. Let me take away the terminal for a second so it doesn't get in the way. So df.error, just look at that. So I need to read through this again because I'm a little confused. So starting with labeled traces, this says 150 examples, but actually I only see 100, or maybe like 101. So I don't know what's happening there. Huh. Yeah, so looking at this, I think the data is not good. um, I'm not sure what's wrong with the data they provided, but essentially, you don't want it to be the case that all of your traces are labeled positively, because that means that you can't improve it or figure out what went wrong. So quite frankly, there's like not really a meaningful way to like continue on this other than to say, you know, we might use Judgy now to go ahead and add this. So Now we can say, what is it? There we go. So we can now do, what is this? Labels, predictions, and then this unlabeled predictions is basically going to be us doing this again, but on the other data set. So I'm just going to make a little helper function, like run all. And so we'll just say you can pass in a data frame, and this is going to return a list of judge responses. And we're basically just going to do this. And then down here, we can do that. And then down here, we can say, await. So now we're going to run it on the test data set here. And now we can basically pass that in. So we might just call this unlabeled preds. And then I want to I don't know what they're doing underneath the hood to do this exactly, but I think it'll be safer to pass that in. Cool. So now let's go ahead and run this. I don't know that I have, let's see, this installed. So let's just make sure. So UV add judgy. Cool. I can run this and see what happens. And so while this is running, we'll talk a little bit about what judgy is doing, because I don't know that that's totally clear. So the idea here is that we have a judge which can automatically label our data, but the judge is another AI program. It could sometimes be wrong. Let me check the stream again real quick. All right, we're good. So the judge is another AI program that could be wrong. And so what Judgy does is we're going to give it some labels and predictions that are paired, meaning that these should be the actual true labels that a human probably gave and the predictions for the same query response pairs. Then we're going to use that to estimate a few things. Basically, we're going to use it to estimate what is the true positive rate and what is the true negative rate. And we're going to later use that to help correct. Because at the end of the day, we want to be able to take this judge and apply it to unseen data that humans are not really going to go through and look at and label rigorously. But we want to make sure that when we look at the judge, when we look at our accuracy, for instance, we want to make sure that it is still in line with what a human would have done. And so the true positive rate and true negative rate give us a sign about how often is that AI judge actually getting things wrong. And we can use that information and those estimates to apply correction. And so with this, we're basically supplying the paired labels and predictions, which allow us to estimate the true positive rate and true negative rate. And then we pass in predictions that are not labeled. So this is a different data set that has nothing to do with these two. And then we can estimate what they call theta hat. And really all that is what would the success rate be if a human went through and labeled everything? And you get that by taking the success rate you have here and applying a correction for the bias that the AI judge has. And then you also compute a 95% confidence interval. So you can basically, because this stuff is a little statistical, right? It's not deterministic. And that means they're a point estimate or just like having a single value for what would the success rate be if a human went through and did it, might not give you a whole lot of information because it might not be exactly that. That's just kind of your best guess. And so in statistics, we often use confidence intervals to show a range of values that we believe the true value could be in. And so if this lower and upper bound are really wide, let's say theta hat is, you know, uh, theta hat might be, 70%, but it might be that your range is like 50% to 90%, and maybe that's problematic for you. And so it's good to look at this to understand, like over time, you really want to do two things. You want to move theta hat up so that, you're getting better and better, but you also want that lower and upper bound to get tighter because that means that you're more certain. Um, Generally, the easiest way to tighten that bound is to get to have more real labeled data. And so ultimately, humans are always going to have to look at data. Now, the correction that's applied that I mentioned is described here. If this doesn't make sense to you or you don't know how you got to this, I have a little write up that I can share. Just DM me on Twitter, LinkedIn, whatever, and I can send it to you. That walks through a derivation of how you get this. But now that we've like talked through what that is, let's come back. So test labels must contain both positive and negative examples. So I don't think that we can actually complete this because the provided data does not have positive and negative examples. What we would have to do from here is basically go through and produce labeled traces that actually have negative examples. And so I don't, I'll kind of like ping the course about this. That being said, this is basically the code that you would be looking at. And what you would do after this, you generally wouldn't do this until you've gone through basically, we're printing out our true positive rate and true negative rate. We would start to look at that and go through an error analysis process on the judge itself to figure out, okay, where is it getting things wrong? And then we would use that to go back up to our prompt and update our prompt. And so part of that would involve adding examples from our training data set into it. We might take some information from this README and put it in there, but that's the basic process. But yeah, to do this, we do need both positive and negative examples. And it's also good practice to put examples with positive and negative labels into the judge prompt directly. But I think that that's it for now. Actually, wait a minute. One thing. Let me check one thing real quick. There's this labeled column. Okay, yeah. I just wanted to see if that was a different, maybe this was the thing. Um, okay, so yeah, so just like looking at that, I think that there's not really much else we could do except go through and label traces ourselves, which I think we've already been on the stream for 50 minutes, so I think that's a little bit too much. So we'll go back to the course makers and let them know that the data only has positive examples labeled in that data set. But hopefully this gave you an idea of what that process looks like. Thanks for watching. If you have other ideas of things you want to see me do and show you how to do live, feel free to @ me on Twitter or LinkedIn. Have a good day.